All right, now let's do another example. It seems like it's just as simple. I'm going to get rid of this. But it'll highlight the problem of using these t results and what we have to do to overcome it. Instead of cos x is equal to 0, let's solve sine x is equal to 0. Do it in the same domain. Okay? So just like before, you say let t equal, you have to introduce it. Never bring in variables without telling what they are. Yeah, question?
No.
Okay, sure. It comes back to you. Yeah?
Is the problem the asymptote?
Yes, that's right. We'll come out in a second. Just like before, I'm going to note down this adjusted domain. Good pickup, by the way. So it's now between, sorry, not 1 pi. Okay. All right. Now, therefore, let's remember this was the result for cos. So the result for sine, rack your brains. It's the other two sides in the triangle. It's
2t equal negative 1 plus x squared.
do you need like some lozenges or something? You sound like you got some problem in your throat.
No, it's fine.
Yeah, okay, great. Yes, that's the result. All right. So that's equal to 0. Okay.
So how much is it?
Now you look at this and you're like, wow, this is even easier than before. 2t equals 0, so t is equal to 0. So tan of x on 2 is equal to 0. And you think about what tan looks like, and remember I'm solving from 0 to pi, right? Where are the two places that tan is 0? Well, it kind of looks like this, right? Okay, this is from 0 to pi. If I went to 2 pi, I'd get another lot of that, right? So where are my solutions for 0? Here at 0 and here at pi, right? So x on 2 is 0 or pi. So therefore you multiply through and you get 2 solutions just like before. So that looks good, right? So just like we did with the cosine question, let's just double check it. Okay? What does sine look like? Sine looks like this, right? And we're solving for when it's equal to 0. So the solutions we've got so far are 0, check. 2 pi, check. Uh-oh. Right, okay. We missed a solution. Poor old pi left in the middle, just like the third child, that was me. What's the matter with this solution? Why didn't it appear? Why did it just, like, we didn't, you can check the algebra. There's nothing wrong with the algebra. There's nothing that you, like, you cancelled out that you shouldn't cancel that. It's all correct. What's the problem? Well, here's the problem. Let's do this. Okay, the problem with t results, no matter what kind of setup you've got, whatever kind of equations, right, is that x can never equal pi. Never, ever, ever, ever. Or any multiple of pi for when it comes to it. Why not? Because this whole way of solving things, right, it depends on tan. Okay? Tan of x on 2. But tan, as you can see by this drawing, right, it's got some problems, right? Tan doesn't exist at pi on 2, right? There's an asymptote there. It doesn't exist at 3 pi on 2. It doesn't exist at 5 pi on 2, and so on and so on and so on, right? So remember, this is x on 2, right? So x on 2 can't equal pi on 2, right? It can never equal pi on 2. Your calculator will melt down, okay? So if x on 2 can't equal pi on 2, therefore you just multiply through by 2, and you get this result, okay? So what does it mean? Okay, you've been talking about how sometimes you can solve a question one way or another, right? And I've been telling you, okay, choose the best way. Choose whichever works out best. Occasionally they will say, solve this and use this specific method. If you remember back to last year, I don't know if you remember, there was a particular formula you learned for if you've got coordinate geometry, okay? You have 2 lines and they intersect, and then there's some third point over here, and you have to find the equation of the line that is concurrent with those 2 other lines and goes through that point, okay? And you can solve this a variety of ways, but there was one way you learned in year 10 called the K method. Does that ring any bells? Like, even if you don't remember how to do it, right? Now, the thing is, sometimes the question said, by the K method, do this, right? Even though it was perfectly fine to do it the other way, it just took a bit longer. And exactly the same way, sometimes they'll say, But the t results show this, okay? Even if they don't stipulate it, right? Whatever you do, once you get to the end, you must test x equals pi, okay? What does that mean? You go back to your original equation and you sub pi it. You see what happens, right? So in this case, you get sine of pi, that equals 0, right? Which satisfies the equation you started with. So you say, therefore, pi, or x equals pi, is one of the solutions, right? So you add it in with the other two that you got, and you get 3 solutions, right? Over here, even though you might know, like it's not going to be x equals pi, you still are obliged to test x equals pi. Okay? You must do it, because the problem with t results is it always misses this solution, okay? So therefore you say, okay, sub it into here, cos of pi. What's cos of pi equal to? It's going to be, I haven't drawn it, I rubbed it off. It's going to be -1, okay? So it's not a solution. So great, it's fine, I don't need to worry about it, okay? But here's the big thing you need to write it in bold, put big red rectangles around it, all that kind of thing. When you use the t results to solve a trig equation, like these, okay, you must test x equals pi every single time, okay? Now, I told you before that this isn't the only place the problem occurs, right? It actually occurs over here as well, and it'll occur again, it'll occur an infinite number of times. So, why do we only have to test x equals pi? Why don't we have to test any other values of x? Any thoughts? Well, where was the next time this problem came up? The next time the problem comes up is at 3 pi on 2, right? So x on 2 is equal to that. So it would miss the solution x equals 3 pi. But 3 pi isn't in the domain, right? And it usually isn't, okay? This is the most common domain you get. The second most common domain you get is minus pi to pi. I think once, in an exercise written by a certain very thorough head teacher, have I seen a question go out to this domain. Apart from that, exams, you never see it. It's always going to be in one of these two domains, basically. Okay? So that's why we say test x equals pi. If the question was a freak of nature, and it's like, yeah, let's solve it from 4 pi to 6 pi or something like that, you'd have to test 5 pi, because that's the odd one. It's just right in between. Okay? But that's rubbish. I've never seen a question like that. Okay? So x equals pi, that's the one you got to test.